This presentation of Princeton's water story is meant to help Princeton residents understand where our water comes from, what happens to it as it runs through town, and where it goes. It's the first step in a process laid out by Sustainable Jersey to help municipalities identify, solve, and manage their water resources. Sustainable Jersey, for those not familiar with it, is a nonprofit that supports sustainability planning at the community level. Princeton's most prominent and best-known water feature is probably Carnegie Lake, which is a great place to start the conversation about our relationship to water because it's complicated. If you ask people how they feel about Carnegie Lake, you get a range of answers. As scenery, it's delightful. You can walk along the canal, enjoy great views of the lake. If we were to post our feelings about Carnegie Lake on social media, we'd probably give the lake high marks for being photogenic. As a recreational venue, it's Olympic class. Carnegie Lake was constructed as a gift to Princeton University back in 1906, so the rowing team would have a place to practice. The lake welcomes small boats, fishermen, even ice skaters on a cold winter's day. Thumbs up for recreation, or at least a qualified kind of recreation. If you were to fall in, however, the water becomes far less appealing. These geese might enjoy swimming in the lake, but the fact that they're there makes the water brown and less inviting for humans to swim in. Swimming is not a good idea. And you absolutely do not want to drink the water or eat the fish you might catch from it. The waters of Carnegie Lake are technically classified as impaired, which means we have water quality problems. Problems much of New Jersey shares. Anyone who gets that close to the water might well post an OMG. When I first heard the term impaired, I was taken aback. What does that mean? It means the water does not meet the standards of purity set by the Clean Water Act. It means fish can survive in that water, but not thrive. And it means that if you catch those fish, you should think twice before eating them. Why is Carnegie Lake water impaired? That's one of the questions we'll try to answer in this presentation, and then look at what we can do about it. Understanding Princeton's water story should help our town formulate an overall water management strategy to improve water quality, stormwater management, including green infrastructure and stream restoration, water conservation, and public understanding of water problems and solutions. It turns out the water story we were told as children is a bit of a fairy tale. The classic illustration of the water cycle doesn't take human activity into account. Yet human footprints on the water cycle are in fact everywhere, especially in our heavily populated and long industrialized state. There is infrastructure. We redirect water with the things we build. There's pollution. We throw things into the water that don't belong. There's governance. We try to manage the water with policies that don't always favor the environment. And there's awareness, or lack of it. We can be oblivious to the impact we make on water. So the true water cycle with a large human footprint would look more like this, with towns, streets, parking lots, domestic, industrial, and agricultural use, dams, wells, drinking water, and disposal systems. You'll notice that both water cycle diagrams have a few things in common. Rain flows downhill, and the waterways form what is known as a watershed, a drainage area that channels all water to a common outflow point. Each tributary to a river becomes the center of its own little watershed. Understanding your watersheds, large and small, is key to protecting water resources, since what happens upstream affects everybody downstream. So here is our first pop quiz. Princeton is in which watershed? A, the Delaware, B, the Millstone, C, the Stony Brook, or D, the Raritan? Note that it's a tricky question, and there could be more than one answer. The answer is Princeton is in the Raritan River watershed, but we are also in the sub-watersheds of the Stony Brook and a part of the Millstone River from Heathcote Brook to Harrison Street. That means our rain, runoff, streams, rivers, and canal waters all drain northward into the Raritan River, which is also, incidentally, the source of our drinking water. Another tricky part to this answer is that even though we are not located in the Delaware River watershed, water from the Delaware River does flow through Princeton, thanks to the man-made Delaware and Raritan Canal. So yes, we get water from the Delaware, but no, we are not part of the Delaware River watershed. I'm going to switch maps for a second to show you the watershed boundaries. This is a Watershed Explorer map created by Rowan University's School of Earth and Environment. It shows the two sub-watersheds in Princeton, the Stony Brook in yellow and the Millstone River in green. Rains that fall in the green section drain directly to the Millstone. Rains that fall in the lower left drain toward the Stony Brook. There are more than 48 miles of streams running through Princeton, about 1/4 of which are considered headwater streams that start within our boundaries and essentially form many mini-watersheds throughout the municipality. When Princeton University's Nassau Hall was built in 1756, it was placed on a high vantage point right on the crest that divides the two sub-watersheds. Several blocks away, Princeton High School was also built on the same crest. There are also maps for the quality of our surface waters, such as streams, lakes, etc. As I mentioned before, most of the surface waters in New Jersey are considered impaired in some way, which usually means they are too polluted for unrestricted use. The Federal Environmental Protection Agency offers an online Surf Your Watershed tool that maps the streams in any neighborhood by assessed water quality. A search by the zip code 08540 yields the following map, with polluted waterways marked in red. Blue means unassessed. You can clearly see that both the Stony Brook and the Millstone are red, but that just gives you a general idea. To know the specific types and sources of water pollution takes a lot more work by a lot more people. To test a constantly moving environment like water is a challenge. Here's another water quality map from the Watershed Institute in Pennington, which has issued a Stream Watch report card for the region, which assigns the Princeton area surface waters a C to an F in several categories, including macroinvertebrates, E. coli, nitrates, and phosphates. This pollution can't be blamed on a single source. Surface waters are generally tested in several ways. Chemical testing includes temperature, acidity, nitrate and phosphate levels, usually from fertilizer residue, turbidity, which is how cloudy the water is from suspended particles, and dissolved oxygen. Biological testing looks for macroinvertebrates that act as canaries in a coal mine. If you examine a water sample under a microscope and find a mayfly nymph in the spring, for example, that's an indicator of a reasonably healthy stream. Bacterial testing mainly looks for E. coli, which can indicate sewage or animal waste contamination. In addition, studies have confirmed the presence of microplastics in the Raritan River, although testing for microplastics is still not being done on a regular basis. Which brings us to the next pop quiz. Why are Princeton's surface waters dirty? A. Stormwater runoff. B. Home and garden waste. C. Animal and bird waste. D. Road salt. Or E. Sewage. The answer, like the brown water, is not clear. It is most of these except the last one, sewage, which gets cleaned up and treated before it's returned to the Millstone River. According to the Princeton Environmental Resource Inventory, the main source of pollution of Princeton's waterways is stormwater runoff, and it's referred to as non-point source pollution, which means that the sources are diffuse, widespread, and cumulative. In other words, the chemicals we use in the course of everyday home and garden maintenance, the animal and goose poop that in many cases goes straight into the surface water without the benefit of ground filtration, the road salts. All of these become a toxic soup that drains into our waterways with every storm. So let's take a look at stormwater. The Garden State likes rain, of course, just not too much or too little. How much rain do we get? Mercer County gets a median annual precipitation of about 45 inches, although our rainiest year since records have been kept was in 2018, when nearly 65 inches of precipitation were recorded. 5 of the last 15 peak crest flood events on the Millstone happened just 2 years ago. Annual precipitation has been trending upward, and climate change projections predict this wet trend will continue. Where does the rain go? Generally, over half the precipitation goes back into the atmosphere, either through evaporation or transpiration from the leaves of plants. Over 1/4 of the water becomes runoff and exits the basin via streams and rivers into the Raritan Bay. The remaining water infiltrates into the soil, becoming groundwater, which then moves slowly back to the streams. The groundwater is a critical source of flow during dry periods, while runoff during storms creates larger but short-lived stream flows. Severe downpours often result in flooding. Princeton lies at the edge of the Piedmont Plateau, which means its soil types are generally slow to absorb precipitation, leading to large amounts of surface drainage, flooding, and siltation. Princeton also has a relatively high water table, which is one reason our floods are often flashy. That is, when rain hits, the flows increase quickly and die down quickly, because not so much is absorbed into the ground. Harry's Brook, for example, which floods often, starts underneath the densely developed Palmer Square and flows underground, giving its waters no chance to soak into the ground until it emerges on the other side of Harrison Street. These pictures show how quickly Harry's Brook can swell during a heavy downpour. Stony Brook, on the other hand, has been classified by the DEP as a Category 1 stream, which means it has exceptional ecological significance and benefits from more stringent water quality protection. DEP requires a 300-foot buffer zone on either riverbank, which helps the ground absorb and filter water more readily. Planting the buffer zone of a stream with trees helps stabilize the stream banks, reduce pollution, and improve water quality. How much do trees help in flood mitigation? According to the National Tree Benefit Calculator, a white oak in Princeton, 30 inches in diameter, will intercept more than 12,000 gallons of stormwater runoff a year. If it were to be cut down, that's how much extra water would be added to the stormwater flow. Shrubs and native grasses have a similar benefit, though in some areas they may have to compete with shade trees for sunlight. Half of the Princeton area is forest or wetlands, where water flow and ground infiltration happens as nature intended it to. However, Princeton also has a lot of developed land, much of which is paved and therefore impervious, and that makes flooding a concern. This map shows Princeton's floodplains in orange. Most of our floodplains lie along the Stony Brook and Harry's Brook. At 59 Meadowbrook Drive in the Little Brook section of Princeton, there once stood a family home known to the neighbors as the Flood House. A succession of floods eventually made this house unlivable, and the municipality bought the property and demolished the house altogether. Corey Kreisiter, stormwater specialist with the Watershed Institute, took this sequence of photographs of the stream behind the flood house, showing the drastic erosion of the stream banks over the course of 7 years. Few people realize, she says, that 1 inch of rain falling over 1 acre can generate 29,000 gallons of runoff. In a year, over 1 million gallons can fall on that same acre. So why doesn't this rainwater soak into the ground? The main obstacle to the natural flow of rainwater is man-made. The impervious surfaces, such as parking lots, roadways, and roofs, that go up with any new building development. Generally speaking, areas with an impervious cover of 10% or more begin to show signs of environmental degradation, such as more stormwater runoff and pollution. As of 2017, 14.4% of Princeton's acreage was covered with impervious surfaces. This steady increase is a concern for water resources. With the Watershed Explorer map, you can visualize the expansion of Princeton's impervious surfaces over the years. This video starts with data from 1986 and goes up to 2015. The darker the purple, the higher the percentage of impervious cover. Princeton is pretty much built out already, but you can see dramatic construction along routes 1 and 206. One way to help the ground absorb more rainwater and compensate for impervious surfaces is by replacing some of the so-called gray infrastructure solutions of the previous decades with green infrastructure. Gray infrastructure includes catch basins and storm sewers, detention basins with concrete channels, and river walls that just divert water flow. Green infrastructure mimics nature's way of absorbing and filtering the flow of water through the use of rain gardens, plantings, natural restoration, and other principles of conservation. The newest version of New Jersey's stormwater regulations requires the incorporation of green infrastructure to meet pollution and runoff standards and decrease the risks of flooding. Separately, the Clean Stormwater and Flood Reduction Act was passed in 2019 that allows towns to establish stormwater utility fees, which could be used to defray the costs of green infrastructure. The new stormwater regulations also require all municipalities to map their outflow by the end of this year. As Princeton does not have a complete or digital map of its stormwater and sewer systems, town engineers are working hard to meet the DEP requirements. In the words of one Princeton municipal engineer, the highest priority this year is to map and understand what we have. A Green Infrastructure Municipal Toolkit has been put together by NJ Future and a Green Infrastructure Manual by Rutgers to help municipalities implement more ecologically sound stormwater solutions. Princeton has some green infrastructure on private properties. Some years back, the stream that runs through Princeton University campus alongside Washington Road was seriously eroding its banks and in need of repair. The stream was partially channeled through concrete ducts, giving the water little chance to infiltrate the ground. The university drew up a plan to restore the natural flow of the stream. After reshaping the stream bed and landscaping the buffer with hundreds of newly planted trees and other plants, the Washington Road stream restoration was completed in 2014 and now flows unimpeded to Carnegie Lake. The concept of green infrastructure is only just beginning to make inroads into the landscaping repertoire of the average New Jersey contractor. In February of this year, the Watershed Institute launched a certification program to help the landscaping industry and the individual homeowners they service adopt more sustainable practices to reduce the number one source of pollution in Princeton's surface waters, which is us. Back to the existing infrastructure, some basic information. Who owns the system? The stormwater system is the property and responsibility of the municipality. The implementation of the stormwater permit is the responsibility of the engineering department. The newly formed Flood and Stormwater Commission makes recommendations to the mayor and town council regarding flooding and stormwater management issues. The Engineering Department, in collaboration with the Stormwater Commission, is to update local stormwater ordinances to align with the new statewide stormwater legislation. Let's summarize some of the stormwater issues Princeton faces: flooding and erosion, pollution from runoff, too much impervious cover, natural stream flows impeded by gray infrastructure, outdated and incomplete maps of the system, ensuring enough staffing and funding for stormwater maintenance, and preparing for climate change. Let's talk about our drinking water. Many people take tap water for granted, and many users don't know where geographically their drinking water comes from, nor what it goes through to become potable. So you ready for another quiz? Where is our drinking water from? A, New Jersey American Water. B, the D&R Canal. C, the Millstone River. Or D, the Raritan River. The answer is twofold. Princeton's drinking water comes from the same river that our stormwater and treated wastewater drains to, the Raritan. It is, of course, treated by New Jersey American Water before it comes back to us. Besides drinking, tap water is used for landscaping, cleaning, and other non-potable use. Less than 20 miles downstream of Princeton, just north of where the Millstone River meets the Raritan, is the intake point for New Jersey American Water's Raritan Millstone Water Treatment Plant in Bridgewater. The plant can treat up to 135 million gallons a day. The company maintains a second, smaller water treatment plant on Canal Road that supports the same service area. Each facility can provide backup supply for the other. In their most recent infrastructure report card, the American Society of Civil Engineers gave New Jersey a C for drinking water, saying the abilities of these systems to provide adequate services is threatened by age, lack of reinvestment, and a short-term focus. The standards for the quality of drinking water are set by the EPA and the New Jersey DEP under the Federal and State Safe Drinking Water Acts. New Jersey American Water regularly tests water coming in and leaving the plant, and publishes the results of its testing, most recently in the 2019 Consumer Confidence Report, or CCR, which is available on its website. Who owns the drinking water infrastructure? New Jersey American Water, an investor-owned water utility, is a subsidiary of American Water. The company owns and maintains the pipes up to the curbside valves. Curb to home is the customer's responsibility. There are some private wells. Private wells and septic systems are the responsibility of the property owners, but their permitting comes under the purview of the town's health department. What are some of the issues associated with drinking water in Princeton? Monitoring and ensuring water quality, vulnerability of water supply to flood or drought, extravagant water use practices, and fertilizer from landscaping that washes into water that drains through our watershed, leading to higher rates of nitrates and phosphates that in turn can lead to the kind of harmful algal blooms that have been closing some of New Jersey's lakes in the summer. When we talk about something going down the drain, the implication is that something is gone forever. But that is not true of the water we use every day, for which the drain is just one more step in a cycle that brings it back for us to use again. Time for another pop quiz. Where does our sewage go? A, Carnegie Lake. B, the D&R Canal. C, the Millstone River. Or D, the SBR-SA treatment plant. And the answer is D, the SBR-SA, or Stony Brook Regional Sewerage Authority, sewage treatment plant in Princeton. After it's treated, the water is returned to C, the Millstone River. This is what the plant looks like. And I asked the manager, Robert Kunert, what he thought the public needed to understand most about water. He said, people need to understand that when water goes down the drain, it's not gone. There's always the same water on this planet, no more, no less. We just reuse it. Back in the 19th century, Princeton, like most communities, used to rely on nature to clean its dirty water. Wastewater from homes like these on Library Place drained into sewer fields at the bottom of Elm Road and filtered into the ground, until the 1930s when the first sanitary system came online. In 1978, the SBRSA's water treatment facility at 209 River Road in Princeton became operational. Sewage is now transported through pipes and municipal pump stations to SBRSA, where it is cleaned up. Princeton maintains the sewage collection system. Our wastewater is pumped to SBRSA for processing. That's where the most obvious solids are screened out. Organic material is removed by a sludge of helpful bacteria. The output is filtered, disinfected, aerated, and returned to the Millstone River. Cost to Princeton, $4.5 million a year. Who owns the sewer system? The Stony Brook Regional Sewerage Authority is a consolidated municipal service established by Princeton, South Brunswick, West Windsor, Hopewell, and Pennington. Princeton Municipality owns, operates, and maintains the wastewater collection system up to the point where it's handed over for treatment. Private property owners are responsible for the connections or laterals on their own property. And a few homes in the northwestern part of town have their own private septic systems. What are some of the sewer system issues? Princeton's stormwater and sewage systems are not combined, which spares us the cross-contamination problems that plague some other Jersey municipalities. But there are still issues to be dealt with. The town is working with incomplete sets of possibly outdated and largely non-digital maps. And there is inflow and infiltration in which groundwater leaks into the sewer system and gets treated unnecessarily, raising costs to the town and risking overtaxing the treatment system in times of flood. Some years back, Princeton had been tackling the replacement of pipes, laterals, and manholes that leaked into the wastewater system, but work on that stopped 4 or 5 years ago because of a staffing shortage. A new sewer engineer has been hired this summer. Now that we've looked at our stormwater, drinking water, and sewage systems, I want to show you how I've redrawn the water cycle to reflect what's really happening in Princeton. First, the natural cycle in green arrows. Rain falls. Some of it soaks into the ground. Some of it runs off, washing across all kinds of impervious surfaces along the way. Surface and groundwater both flow downhill to the Millstone, the Raritan, and eventually the bay. Water evaporates or transpires back into the air from the leaves of plants, condenses into clouds, and falls again. Add to that the man-made water cycle, indicated in blue arrows, which includes diverting water from the Delaware River through the canal, treating and delivering drinking water from the Raritan River, and then after we've used it, treating wastewater and sending it back into the Millstone River. Just to see if you've been paying attention, here's a question. Where in this Princeton water cycle does our water get dirty? There's our wastewater, of course. Household sewage goes down the drain for treatment. Garden water soaks into the ground, often with a lot of dissolved fertilizer nutrients in it. And there's stormwater runoff that carries road salts and other chemicals into our storm drains and waterways. And where in this cycle does our water get cleaned up? There are the treatment plants. New Jersey American Water cleans up water from the Raritan River to drinking water standards. The SBRSA cleans up our wastewater to a level just as clean or cleaner than the water in the Millstone River. And then there is nature's solution, infiltration. Water that soaks into the ground gets cleaned up through natural filtration. And that is why green infrastructure is so useful. Finally, and a little harder to visualize, we should think about how water is affected by our choices and our behavior as individuals and as a society. How are we planning for future climate change scenarios, including more flooding or drought? What policies should we adopt at all levels of government? And what opportunities are there to participate at both the collective and individual levels? Here's a look at some of Princeton's plans. New Jersey has had to cope with 3 destructive hurricanes in the past 20 years. The first of these, Hurricane Floyd in 1999, caused over $1 billion in damages across the state and prompted a surge in flood planning. By 2005, Princeton had commissioned a flood mitigation plan. Hurricane Floyd also flooded out New Jersey American Water's Raritan Millstone treatment plant, which has since been upgraded with higher flood walls and better emergency backup. Last year, the Princeton Town Council adopted a climate action plan developed by Sustainable Princeton, outlining strategies to reduce greenhouse gas emissions and plan for climate change resilience in anticipation of flooding from heavier rains and infrastructure damage from flooding and storms. In addition, the Princeton Office of Emergency Management, which handles hurricane season preparedness, among other things, recently added a climate change hazard annex that addresses the risks of more frequent and intense floods. Princeton also has a community master plan which was adopted in 1997 and is being updated and made more environmentally relevant this year with the addition of a green building and environmental sustainability element. One of the new goals is to decrease impervious cover to less than 10%. And it's not just at the municipal level that people are looking ahead. Princeton University unveiled its own campus stormwater management plan in 2019 and pledged to use green infrastructure like porous pavement, stream restoration, rainwater harvesting, green roofs, and rain gardens into all future campus development plans. You can find more details of these plans online. While a lot of our water supply and quality is governed by federal and state regulations like the Clean Water and Safe Drinking Water Acts, the local and regional responsibility for protecting our waters is especially important in New Jersey, where home rule is dominant. That's where organizations like Sustainable Jersey come in. Sustainable Jersey recommends and certifies best practices at the community level. Princeton has already earned Sustainable Jersey's silver status. A new set of gold standards has just been unveiled for water issues. Knowing our water story is the first step. Formulating an overall water strategy is the next. And with enough momentum, Princeton could be the first Jersey municipality to achieve water gold. This would involve taking some or all of the following actions: green infrastructure planning and implementation, enhanced stormwater management through ordinance, mapping, monitoring, and maintenance, water conservation, education, and ordinance, forestry management plan, integrated water planning, restoring and protecting groundwater recharge, volunteer water monitoring, riparian buffer area ordinance, winter road salt management, and watershed-wide stream restoration. Individual municipalities can't just push their water problems downstream, nor can they make water plans in isolation. Collaboration across the entire watershed is essential to protecting any water resources. A number of successful collaborations already exist. We've talked about Sustainable Jersey, which was the catalyst for this water story. the Watershed Institute with a host of activities at the individual, educational, and policy levels, Jersey Waterworks, which addresses water infrastructure issues, the Association of New Jersey Environmental Commissions, the Alliance for New Jersey Environmental Education, New Jersey Sustainable Business Council, and so many more. Some of these nonprofits are hosted or supported by research institutions based in higher education. Some of Princeton's most innovative ecological projects have sprung up from the grassroots, so to speak. Take, for example, the Ecolab at Princeton High School, an idea fostered by longtime environmentalist Stephen Hiltner to teach kids good environmental practices. There are many other ways to participate as individuals. Anyone can contribute to good planning and policies through civic participation. Most of the commissions and nonprofits involved in sustainability work in Princeton rely on the dedication of citizens, often volunteers, sometimes retired experts in their field, to take on tasks ranging from citizen scientist roles like water testing to citizen oversight on boards and commissions. As residents, homeowners, and gardeners, we can all be more aware of the water and change some of our ways, like using less water, reducing the use of harmful chemicals, adopting greener practices in our own gardens. There's a lot of outreach and training available in our area to get tips and guidance on how to make a rain garden and fill it with native plants. Jersey Friendly Yards, for example, has given workshops on how to build a rain garden in as little as 2 days for as little as $500. That's at jerseyyards.org. So I leave you with one final quiz. Who owns the water? A, the state of New Jersey. B, the public. C, New Jersey American Water. D, whoever owns the land under it. And the answer is B, the public. It's our water. In New Jersey, all natural waters are considered public trust resources, held and managed on behalf of the public, including future generations, by the state. We all own it, we all use it, and we should all protect it. Thank you for your interest in Princeton's water story. Today's presentation is just the outline of a broader report available on the Sustainable Princeton website and containing more detailed information. Please feel free to browse the site or download the PDF. Sustainable Princeton is looking forward to community feedback on water questions. My name is Donna Liu. I am a Princeton resident and a former journalist. This report on Princeton's water has been done in coordination with Sustainable Princeton and the Rutgers Environmental Stewardship Program. I want to say that this work would not have been possible without the deep knowledge of all the people who shared their information and expertise with me. Thank you for your generosity, and I hope it will lead to good things.